Hi friends, welcome back to Mizora Six Sigma Yellow Belt series, and today we are going to learn about binomial distributions. Before getting into binomial distributions, I hope you understand what is a distribution and how we can use it. Today I am going to share with you with an example how can we use binomial distribution, okay, or where it is used. So let's take an example. So let's take a generic example and then I will share with you how we can use it in our processes. Okay, let's take an example. Suppose you have a coin, right? Suppose you have a coin. What will happen if you toss it, right? Either it will be a let's write here, either it will be a head or it will be a tail, right? This is, suppose you have one coin. What will happen if you have two coins, right? So if you have two coins, the first coin, when you toss it, it can be a head or tail, but the second coin, when you toss it, it can be, the first time it can be a head or it can be a tail. For this also, when you have a tail in the first coin, here it can be again a tail and can be a head, right? So the total possible outcomes are, first time it can be a head and head, second time it can be a head and tail, third time it can be a tail and head, and the last time it can be a tail and tail, right? And here you can see we have, in this entire outcome, we have 1 2 3 4 heads and 1 2 3 4 tails, right? So we can say that if the coin is fair, we have 50% probability that we will get 4 tails, and we have 50% probability that we will get 4 heads, right? Similarly, if we increase the number of coins, now let's take another example where we add the third coin to it, 3 coins, right? So let's take an example where we use 3 coins, right? So the first coin number 1 head, and your coin number 2 can be head or tail. Coin number 1 can be tail, and coin number 2 can be head and tail. Again on the third, here it can be again head or tail, head or tail, right? Just simply write down HT everywhere and you will get your outcomes. But this is for your understanding, I am sharing like this. We will get into Minitab and see how it we can do it in Minitab. So now the possible outcomes are, you can see here, the first outcome is head, head, head. The next can be head, head, tail. The next can be head, a tail, head, H, T, T, head, tail, tail, T, H, T, H, T, right? T, T, H, and finally T, 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 right? Now let's count all this. In the first coin, we had 2 outcomes. In the second coin toss, we had 4 outcomes. In the third coin toss, we have 1, 2, 3, 4, 5, 6, 7, 8, right? We have 8 outcomes. Now we can say here, with each of the coin toss, we have 2 to the power n, right? which is where n is the number of trials we have. So if we have 3 number of coins where 3 number of trials are there and the outcome is 2, then our total number of outcome would be 2 into 2 into 2, right, which is equal to 8, correct? Now let me show you the same thing in Minitab so that we can understand it later when we integrate the process into it, right? So let's take an example. If I have to do it in Minitab, I'll simply go to graph and go to probability distribution plot and view probability. Okay, now I have already selected it, binomial distribution. Let's take an example. We have 3 trials and the event probability in case it's a fair coin, you have 50% chances, right? So number of trial is 3. We have event probability as 0.50. Okay, now you can see here what is our probability of getting a 0. You can see here the getting a 0 is 0.125. So we have 12.50% chances that we will get a 0 success. I'll get into what is a success here, right? Here we have 0.375, so that is 37.5% success. This is 12.5, this is 37.5, so that is 50%. And the rest again you can see this is also 37.5 and 0.125, right? So here what we were asking is, if we go back to this, we were sharing number of trials was 3 and what is the event probability? Event probability was 0.50 in the shaded area. Now what we will change is, let me change to x values. In the shaded area, now I want how many success I will get of minimum 2 success, right? Minimum, what is the probability of getting 2 successes? I'll tell you what is success and what is failure. Now here the probability, if I run a trial of 3, the probability of getting minimum 2 successes is 87%, right? Now let me tell you what is a success and how do we relate it to a process. Now in this example, when we had taken head or tail, here we can take either head as a success or tail as a success. It depends on what we want, right? Now let me go back and share another example with you so that you can understand it clearly, right? So before we get into the example, there are a few properties of binomial distribution where you should use it. The first use of a binomial distribution is when you have 2 outcomes only, 2 results possible. It should not be 2 or more results of the outcome. So it should be a pass or a fail, like a head and a tail, right? Outcomes are mutually exclusive, means if one outcome happens, the other cannot happen in the same product or same services, right? Each trial is an independent event. That means whenever we are the first trial, first coin toss, there is no relation between the first coin toss and the second coin toss. That is independent of trials. And the minimum sample size for this calculation to be accurate is greater than 50, right? Now let me take this example where you will understand now where you can use this. So suppose you are working in the audit or QA QC department where a product or services has to be rejected or accepted, right? That's the success we are targeting, rejected or accepted for a sample study of 1000, right? So what you have here is, let me show you here. Suppose you have 1000 samples, right? So you have a consignment. Let's take, you have a pharmaceutical organization and you have maybe lakhs of drugs here. Out of this, the pharmaceutical company has told, your client has told you, we will take 1000 samples and audit this. And if this audit percentage shows 15% or more failures, that is failures means the product which is available here does not meet the requirements of client, that is if it is greater than 50%, 15%, then they will reject this lot, right? In the meantime, when it takes time for this 1000 samples to be checked, you want to know what is the probability that you will lose this consignment, right? What is the probability that this consignment may not go, right? Now you have historical data where you know that the rejection rate or the defective percentage in this consignment, the defective rates of this consignment is 10%, right? This is historical data. Now you want to assess and tell your management, see, based on the historical data, I see we get about 10% rejection. Now if the service level agreement is 15% from the client, then what is the probability that you will lose this consignment, right? Let me take you to Minitab and share with you how. So let's try to do this in Minitab and see how we can calculate all this. We'll go to graph, probability distribution plot. I want to view the probability, right? And that is okay. I want to see for binomial distribution, our number of trials is 1000 and event probability is 0.10, right? And let me go to shaded in probability. I want to see 15% probability, or in the X value I want to see 150 defective products, right? Now you can see since this entire probability is lying between 71 and 149, we have 0% chances that we will get 15% of defective products, right? So you don't your consignment will be through and there is absolutely no chances that it will get rejected. So that's how you use binomial. That's how you use binomial distribution in a process calculation. Let's now change these numbers a bit. Let's now say that the event probability is 10 and let's take the event probability is 0.05 and keep all the other numbers same. This we still want to see 5%. Now where, so this you can see 71 149 between. Now if I click OK, now if you see the defective products are even reduced in range because our defects have reduced from 29 to 87%, and each of this number what it represents, this is X equal to 50. So what is the probability of getting 50 products as defective, right? So this number here tells you it has only 0.05% probability. Now let me change again. Let's increase this to, suppose you have historical event of 25% defective products, right? Now if you see, you have almost 100% chances that you will get more than 15% defective products, right? Now let's take it to change it to exactly 15. So let's say our defective products is 15% in our historical data, and what is the probability that the consignment will be rejected this time, right? So you have almost 50% chances that the consignment will get rejected, right? So that's how you use binomial distribution in the process calculation and your own process areas, right? Hope you understood this. Any doubts, anything, share in the comment section and we will respond to it. Next we will discuss about correlation and regression. Thanks a lot.